Now, one way to analyze this model is to look for what we call a steady state. And in a steady state, everything's constant, right? You guys take it macro. So macro always talks about steady state. They often do steady state with growth. That's just to make the world look pretty. We're just going to do steady state without growth because that's everything you need to know, but simpler. And so my steady state equations are just the constant versions of the same four equations I put on the board there. Number one is K bar, the steady state stock, has to be the amount that people demand at R bar, right? So just same use market equilibrium I had. The other one is P bar equals R bar. Remember, if R is constant, then I can factor R out of this equation and then just sum this geometric series, right? So that sum of that geometric series is 1 plus R over R plus delta. That's just the sum of that geometric series, okay? You know, which you can kind of see, like if delta was 1, then it's non-durable, and its P bar is R bar, so that's the world. If delta was 0, then it's, you know, the usual kind of story, okay? Any questions that people have? All right, then the next equation is I bar equals I of P bar. And the last equation is I bar or K bar equals I bar over delta. Right? That is, the steady state stock is just the steady state depreciation, steady state investment divided by the depreciation rate. Or I bar equals delta K bar. We're investing just as much as depreciation, right? This is equivalent to I bar equals delta K bar, which kind of clearly gives you a steady state because it means investment is equal to depreciation, so the stock stays constant. Okay? Now, we can find the steady state pretty easily because we can make a graph where we put K on this axis and R on this axis. We could put I there and P. We could do whatever we want, but I like this way of doing it. You can draw your demand curve directly on this space, right? Because the demand curve is already in this space. And then you can combine these three equations together by plugging this into here, you get what I'll call a steady state supply, which is just 1 over delta I of R times 1 plus R over R plus delta. So that's the picture. Okay? And that determines my steady state. Did I do this last time? I don't think so, right? I didn't. R bar and K bar. That's how you would determine the steady state. Okay? But you see how that works? We'll see why. Okay? Now, if this was all you were going to do with it, then we're wasting our time. Okay? Because in terms of steady states, there's nothing interesting about durability really in the steady state, to be honest. That is, this demand curve has the elasticity the same as it is the regular demand curve, and the elasticity of this supply curve is just the elasticity of this I function. Because all we've done is rescale things. We just rescaled R, and all we've done is rescaled I. So we really, you know, steady states, durables, non-durables, capital, this is not an interesting concept. Steady state is like you'd expect. What's interesting about the steady state, though, is it's telling us where this system is going to go. It tells us where we're going to evolve to.